Hello everyone, welcome back to Olsen Cafe. Today we are going to learn how to differentiate these exponential functions. Now beside the basic rules, most students will instinctively use product rule or quotient rule here. But what I am going to show you in this video will actually blow your mind. I am going to just use one simple idea and you will be able to find the derivatives pretty easily. So let me show you how we can do this quickly, one step only. Let us first take a look at the basic rule when differentiating exponential functions. So given any exponential functions, what we are going to do is we are going to keep the exponential functions and then we differentiate the exponent, or we call it the index. Now let me go through two examples. So given y equals to e to the power of x squared plus 3, to find the derivative, what I am going to have is I am going to keep the exponential function, which is e to the power of x squared plus 3. Then I'm going to differentiate the index, which by power rule, I will get 2x. So putting them together, I will easily have the derivative equals to 2x times e to the power of x squared plus 3. Now let's take a look at another example. I will have y equals to e to the power of sine 4x. So if we are going to keep to the exponential function, what I will focus now is to differentiate the index. So we have learned earlier on to differentiate the index. This will give me 4 cosine 4x. Right? So putting this together, so I will get the derivative equals to 4 cosine 4x times e to the power of sine 4x. So this is the basic rule that all of us need to be very familiar with. With the understanding of the basic rule, now let us proceed to find the derivative for this exponential function. Now, so for us to take a look at this, many of us will understand that we will have to apply product rule because there is a product of two functions. So using product rule, let's recall the product rule formula, all right, which is simply equals to I fix the u, all right, and I differentiate v prime, then plus v times u prime. So I'm going to apply this product rule over here. So what I'm going to do is I'm going to step by step. So I let u to be equals to e to the power of 2x and v equals to sine 3x. So u prime, this will give me 2e to the power of 2x. So based on the basic rule, I keep the exponential functions and I differentiate the index. Now let's take a look at v prime. So we should know this well by now. So which means I'm going to differentiate the 3x. This will give me a 3. So which means v prime here will give me 3 cosine 3x. So putting all these together using product rule, so I'm going to have u, which is e to the power of 2x, times v prime, which is 3 cosine 3x. And then I'm going to add on with the second half, which is plus v, which is sine 3x, times u prime, which is 2 times e to the power of 2x. Now, I can easily leave the answer like this, or I can simply just factorize the common factor, which is the exponential function e to the power of 2x, and this will give me this times brackets 3 cosine 3x plus 2 sine 3x. So this will give me the answer very easily. How about these functions here? All right, there is a division, all right, between two exponential functions. So definitely we will need to use the basic rule. But at the same time, many of us will be thinking that since there's a division, so therefore we should use quotient rule. Do you really think so? Well, you can. All right, but over here, I will suggest that we are not going to use quotient rule because this will only make the working very tedious. So what I am going to do over here in this case, I am going to just show you that one simple idea, all right, that can help us to find the derivative very easily. Now, what is that simple idea over here? All right, so what I'm going to do is I'm going to rewrite this function, all right, as e to the power of sine x divided by e to the power of cosine x. Now, if you are familiar with the laws of indices, what we can do here is, since both functions have the same base, I can simply just use law number 2. All right, I can rewrite this as e to the power of sine x minus cosine x. So now I have an exponential function with an index. So using the basic rule that we learned today, so what I am going to do is to find the derivative. All I simply need to do is to keep the exponential function and I just differentiate the index. So to do that, so let's take a look. Sine x, when I differentiate, I will get cosine x. Whereas for cosine x, when I differentiate, I will get negative sine x. So putting this together, all right, the derivative therefore will give me cosine x plus sine x. And then I multiply with the exponential function, which is e to the power of sine x minus cosine x. So over here, I have found the derivative without even using quotient rule. So what I would like all of you to do is you may try to use quotient rule to differentiate this expression. You will probably able to derive the same answer, but you notice that the working it is a little bit tedious. So hopefully after trying out quotient rule on your own, you will be able to see that this little trick that I showed you here will help you to simplify your working and get the answer very quickly. So what is the simple idea that I am talking about in this video? All right, it is to stop memorizing the rules. All right, so in this lesson, what I have done is I applied laws of indices to help me simplify the expression. All right, before I differentiate, I can see for yourself. All right, the working become much simpler. Yeah, so over here, all right, is something whereby I emphasize many times. So take a look at the expression. Are we able to simplify first? And then if you are able to, right, do that before you even differentiate. So good calculus students always simplify first. All right, so do remember that. So let's take a look at this expression. We have y equals to e to the power of 3x minus 2ex divided by 3e to the power of 2x. Would you straight away apply quotient rule, or would you apply what I just shared today, that is to simplify first before you differentiate? So do let me know in the comment below, all right, how would you proceed to find the derivative over here. Thank you for watching this video. I hope you found this useful. If this helped you, please like and share the video. See you in my next lesson. Bye.